Welcome friends, in this video we are going to look at mathematics paper 1 for the year 2023, and this is a continuation where we are starting from question 17. The diagram shows triangles P and Q. Then the question, describe fully the single transformation which maps triangle P onto triangle Q. So the word maps simply means changes or change. Now the triangle that went into a certain change is triangle P. So this triangle P is considered to be an object, while triangle Q is our image. So this is a transformation topic. Now, how can we describe? So for us to describe the single transformation, first we need to look at among the 6 transformations that we have, which transformation suits the description that we have here. So let's consider this point as point A. So the point A image is this one. Then B, so B image is this one. C image is this one. So if we were to draw the straight lines, you can see the type of movement. So whenever we have this kind of mapping where the shape, number one, the shape remains the same, the image has not rotated, so it has just moved in a straight line. Okay, so this is what we call a translation. So we are dealing with a translation kind of transformation. Now what are we supposed to have for us to describe translation? So for us to describe translation, we need a translation vector. How can we find the translation vector? We use this formula: translation vector plus object is equal to image. Okay, so if we make translation vector the subject of formula, then translation vector is equal to image minus object. Okay, so let's say we get the coordinates of A. So the coordinates of A is -4, 6. So we need to write them in the column vector, -4, 6 minus, then we know that this corresponds to this. Then for this one, it's 2, 2. So if we are able to find the answer, so the answer will be -4 minus 2. Since negative times positive 2 is -2, here we are going to have 6 minus 2, which is our final answer is -6. Then here we are going to have 4. This is our translation vector. Or if you want, you can get the point for B and the B image. The answer will always be the same. So the point here is that you can choose any of these. The answer will always be the same. Now, after we have the translation vector, we can now describe this. We can say triangle P was mapped onto triangle Q. Onto triangle Q by translation with a translation vector. With a translation vector -6, 4. So to summarize this, we are saying whenever you are trying to describe translation, remember to include the translation vector in your description. Now we can move on to question B. In the answer space below is an incomplete flowchart for calculating the volume V of a cone. Given the radius R and height of the cone H, complete the flowchart. The formula is volume is equal to 1/3 times pi times r squared times h. Now 1/3 is constant. Even pi is constant. So whenever you are given or you have a formula where you have some constant values, those constant values are not considered to be the inputs. So the only 2 inputs that we have here we have the radius is the input and the height. So the first parallelogram here, we need to put the input here. So we'll say enter r, which is radius and height. Then here we are going to calculate. Now we just have to write the formula. V is equal to 1/3 times pi times r times r multiplied by another, which is h. So this is our final answer. We've completed this one. We move on to question 18. Z varies inversely as the square of x. So whenever we have inversely, we need to make it a fraction. So it's 1 over. Now square means the letter must be squared, so we need to raise it to the power 2. Then and here we have this and directly as y, so the y will be on top. Then let's make the equation. So we'll say z, then this changes into an equal sign, then we introduce the constant of variation, then the k will multiply with y over x squared. So k and anything that is directly must be on top. Now anything that is inversely, remember to put it on the bottom. So this is what we have done. Now the first question is, we want to find the value of k, the constant of variation. Now the values that we are going to use for us to find the value of k, we have been given z is equal to 6, x -3, y 27. So let's substitute that. So for z, where there is z, we put 6, k is what we are solving for, y is 27 divided by our x is -3 since it's squared times another -3. So here our task is to find the value of k. So 1 times k times 27 will give us 27k. Now what I think we are going to do here, we are just going to say 6 times, if we want we can say 3 times 3, or we can just write them like that. But let's expand. -3 times -3 is 9. So I'm not going to multiply 6 by 9. I'll just leave the numbers like that. You'll see why we are going to do that. Over 27. Over 27. Now instead of writing 27, 27 is same as 3 times 9. So we can break the numbers, or if you want you can write over 27, as long as you are able to reduce the number. So you need to look at what works for you. Then here we'll have k, so that this and this can cancel. 3 into 6 is 2. So the value of k is 2. B, the value of z when y is equal to -6 and x is equal to -2. So z is equal to ky over x squared. So we want to find the value of z if the y changes into -6. So what's our k? K is 2. Y is -6 divided by the x is -2 times another -2, which is -2 squared. Now whenever we square the negative, we know that we are going to get a positive. So what I'm going to do here, I am going to say 2 times -6 over 2 times 2. So even this one, I'm not going to multiply for me to get a positive 4. So I'll just write them like this so that I can cancel this one. Then z is equal to 2 into -6 is -3 as our final answer. Then we move on to C. Z is equal to ky divided by x squared. What is the value of y? Is 8. K is 2. What is z? No, I'm sure when substituting I've made a mistake. Okay, so the z is 1. The z is 1. K is 2. Then what's our y? 8 divided by x squared over 1. We cross multiply. So 1 times x squared is x squared. 2 times 8 will give us 16. Then we take the square root of 16, which is, we get plus or minus 4. That's our final answer. Okay, so we move on to question 19. Paul invests 50,000 kwacha in a government bond at 9% simple interest per annum. How much will the bond be worth after 3 years? So we are going to convert what we have into simple interest. So let's find the simple interest. Simple interest is equal to, we need to find the principal times time multiplied by rate. Everything divided by 100, which is, in initials we can just say PTR. So for this PTR formula, we'll say simple interest is equal. So the interest, the principal is the money that was invested. So the money that was invested is 50,000, is what we are going to put where there is P. So where there is P, we put the money that was invested, multiplied by the time. The time is always measured in years. So make sure if sometimes given a question in months, please remember to convert into years. So the time is 3 years multiplied by rate. Rate is the percent given, which is 9, divided by 100. Okay, we can cancel this. So we have 500 times 3 times 9 will give us 27. Now, how do you multiply numbers like this whenever you have 2 zeros at the end on the right side? So you can just write the zeros like this. Then if I remove the zeros, the number that I have is 5. So I'll say 5 times 7, 35. Carry 3. 5 times 2 is 10 plus 3, 13. So 13,500 was the bond or the simple interest that she got. Depends on the amount of money that she invested. Then we move on to question B. 2 cylindrical tins are geometrically similar. The radius of the base of the smaller tin is 6 centimeters and that of the bigger tin is 9 centimeters. Given that the volume of the bigger tin is 108 centimeter cubed, find the volume of the smaller tin. So we'll say bigger tin, then smaller tin. Okay, the radius of the smaller tin is 6 centimeters. Here we have 9 centimeters. So what we are supposed to do, we need to convert these two radii into ratio, which is the scale factor. Now, how can we do that? We need to find a number that can go into 6 and 9 without leaving a remainder, which is we divide by 3, also here by 3. So to get rid of the units, we need to put centimeters also here, even here, centimeters, so that if we cancel this, we have 3 into 6 is 2, then 3 into 9 is 3. So the scale factors are 2 to 3. So these are scale factors. Now, since we are doing the volume and we know that the volume is raised to the power 3, what are we supposed to do? These two scale factors must also be raised to the power 3. So say 2 to the power 3, 3 to the power 3. Let's expand these two numbers. 2 raised to the power 3 is 2 times 2 times 2, which is giving us 8. 3 raised to the power 3, it's 3 times 3 times 3, which is 27. Then upon reaching here, let's go back to our question. Given that the volume of the bigger tin, so for the bigger tin, we have it is 108. We are going to write it here. Then here we put x, then we cross multiply. 27 times x is 27x. Then here I'll just say 8 times 108. Please don't expand these numbers. So the reason why I'm not going to say 8 times 108, then I make one number, divide by 27. Sometimes you may get the bigger number that you fail to divide. But leaving them like that, you see why we are doing that. So over 27 over 27. Okay, we know that 108, if we divide 108 by 2, will give us 54. And you know that 27 plus 27. So let's see, maybe if I can make it easy for you. So 27 plus 27 plus 27 plus another 27. 7 plus 7 is 14 plus 7, 21 plus 7, 28. We keep the 2. 2 times 2, yes, 4 plus 2. We have 6 plus 2, 8 plus 2, 10, which is 108. So 27 can go into 108 4 times. So it's 8 times 27 into 108 is 4 centimeters cubed. Then our final answer is just 8 times 4, which is 32 centimeters cubed. So that is, or maybe if you want, you can use the usual way where we say we find a number that can go into 108, which is 3 can go into 108, also into 27 you reduce. 3 into 10 is 3, remainder 1. 3 into 18 is 6. 3 into 27 is 9. 9 into 9 is 1. 9 into 36 is 4. 4 times 80, we still get the same. So what I think and I can advise you is that you need to look at what you think works for you as a person, because sometimes what may work for me may not work for you. So you stick to what you think is easy for you. Okay, so we have question 20. The diagram shows a right angle triangle ABC. BC is produced to D. AC is equal to 13 centimeters and cos BS is equal to 12 over 13. Find the value of tan ACD. So the value of ACD, this value here. How can we find this value here? So this is an exterior angle. We can't go direct by finding the exterior angle. We can find the interior angle. How can we find an interior angle? So if this is the interior angle is the angle of consideration, this is our opposite, adjacent, hypotenuse. The adjacent is the angle, I mean the distance next to the angle under discussion. Now before you look at tan, first let's look at to the cos that we are given. Okay, let's remove these. So cos BAC, this one here is giving us this. Now if you go back to trigonometry from the Sokatoa, cos goes with cap. So cos theta is equal to adjacent over hypotenuse. So cos this one is this angle BAC, which is the middle letter represents the point where the angle is. So this adjacent will go with this number here. Then the hypotenuse will go this number here. So if the angle of consideration is here, this is our opposite, this is our adjacent. So from that 13 hypotenuse we have it. Then this 12 is our adjacent. Okay, so that cos has helped us to indicate these numbers and to show where they are supposed to be. So after we are done with this part, now let's go back to tan. So we can now go back to tan. Okay, so if this is our tan, so the angle that we are trying to find here is the angle ACB. ACD. Now, for us to find the angle ACD, we need to find the angle ACB, the inside angle. Then from there, we'll look at how can we find the exterior angle given the inside angle under trig. So if this is our theta, so this distance is opposite, this distance is hypotenuse, then we have adjacent here. So the tan theta is equal to opposite over adjacent. Now, we have opposite, we have it. We don't have the adjacent. So how can we find the adjacent? Now, this will now require us to use Pythagoras theorem. How can we use Pythagoras? So for Pythagoras, we are going to use letters. We'll say this distance is A, this one is B, this one is C. So the formula for Pythagoras is C squared is equal to A squared plus B squared. Now, since we are solving, if you are solving for A or B, so this will be B squared is equal to C squared minus A squared. So whenever you are solving one of these two smaller distances, then the formula is the given distance, one of the given distance from the smaller sides must be subtracted from the square of the hypotenuse, which is B squared is equal to, what's our C? 13 squared. What's our A? 12 squared. Which is B squared is equal to 13 times 13, 169. 12 times 12 is 144. Then the difference between these two numbers will give us 25. Then we take the square root here. B is equal to 5. So here there is a 5. We can now proceed by finding that. So we can say tan ACB, this is the inside angle, is equal to 5 over opposite, so not 5, 12. So the opposite is this one over the adjacent 5. Now, therefore, tan ACD. How can you find, if you have this angle here, how can you find the outside angle? So the outside angle is, you just have to introduce the negative to whatever that you have. So negative 12 over 5 is the final answer for that one. Okay, so we go to question. Find the equation of the straight line passing through the point and is parallel to the straight line whose equation is 2y minus 3x is equal to 5. Okay, so we have two lines. There is this line, another this line. So the equation 2y minus 3x is equal to 5 represents one of these two equations. Then the coordinates negative 2, 3 is for the other one. So we are going to use one of the concepts since the two lines are parallel. Now, what is the equation of the straight line? The equation of the straight line is y minus y1 is equal to gradient, open brackets, x minus x1. So we have the x1, we have the y1, we have it. So what is needed is we need the gradient. Now, we can't use the formula of y2 minus y1 because we only have 2 coordinates. For that to work, we need 4 coordinates. So now how can we do that? So let's find the equation of this line here. So the first step here is make y the subject of the formula. So that's what we are going to do. So anytime without y, we shift it to this side. So negative 3x will go to this side, giving us 2y is equal to 5 plus 3x. Then to isolate y, we divide by 2, also 2, also 2. Then y is equal to 5 over 2 plus 3 over 2x. After we are done making y the subject formula, when there is y, we put m, symbol for gradient. Now the value of the gradient, whenever the y is the subject formula, is the coefficient of x. Any number, including the sign, represents the gradient. So from there, our gradient is 3 over 2. So this is the gradient for this line, 3 over 2. If 3 over 2 is the gradient for line A, what is the gradient for line B? The gradient for line B will also be 3 over 2, since these two lines are parallel and whenever there is a condition of two lines being parallel, then the gradient of those two lines must be equal. Y minus y1 is 3, this one here. Gradient 3 over 2. X minus -1. So 3 over 2, negative times negative is positive 2. We can now expand. 3 over 2 times x is 3 over 2x plus 3 over 2 times 2 will just give us 3. Since 3 over 2 times 2, these 2 and these 2 will cancel. Then we can collect the like terms. This one will shift to this side. Y is equal to 3 over 2x plus 3 plus 3, which is our final answer is 3 over 2x plus 6 as. So this is the equation for this line. Okay, so the point is whenever two lines are parallel, gradient 1 must be equal to gradient 2. So that's it for this video. Thanks for watching, and if you find this video interesting, please give it a like and comment. Your comments, they are very important so that we see where we are heading to.